Now, average of this, okay, is nothing but the summation of all these numbers. Okay, there are a couple of ways in which you can do it. Okay, the first way is you can just sort of use this equal to formula. Okay, equal to, and you say sum, and you identify all the values in the data set and close it. Okay, this is the sum of this. Okay, I'm just making a little space here. Right, this is the sum, and this is the total number of observations, and let me call that is equal to some count. So it counts the number of observations in the data set, and I'll say average. Average is this number divided by this number. So I hope all of you are comfortable with what I just did now, because some of you did respond in there. They're saying they're beginners to Excel. So just trying to be doubly sure that you're comfortable. Okay, anyone not comfortable, please tell me now. Okay, all right. Now, I'm just highlighting this. I'm just sort of formatting this. Okay, so I have the sum, I have the total number of observations, I have the average. Okay, now for this B school B, all that I'm doing is I'm taking this and I'm dragging it to the adjacent column. I'm just pulling it to the other column, and I'm getting the average. I'm getting the sum, the total number, and the average for the other B school also, B school A and B school B. Okay, so please understand that when I just drag this, three things happened here. First is the format got copied. Okay, I had formatted it as bold and in yellow. That has got copied. It has copied the formula, like say for instance D14 to D15, D14 by D15, whereas the formula which I originally gave was C14 by C15. Okay, when I just copied it to the adjacent cell, that formula got transferred to D14 by D15. So the formula also got shifted by one angle, one cell. Okay, and this particular property of Excel, this is one of the most important properties of Excel. This particular thing is called relative referencing, relative cell referencing. So whenever you copy paste a formula, or whenever you copy paste anything from a cell to another cell, three things get copied. The formatting of the cell gets copied, the relative referencing gets copied, and relative referencing, formatting, and the mathematical formula. Three things happen. Okay, so this might look simple now, but we'll come to this later. Okay, now let's look at the median. Median, of course, is arrange this in the ascending order and pick out the value at the middle. Okay, so this is the crudest way of doing it. Of course, Excel has got more advanced formula, because I am just getting this feeling that you guys are comfortable with this. So I'm just moving to the next stage, which is instead of doing this in this sort of roundabout way, we can directly use the formula. Okay, for Excel, you have the formula, which is average. And I just select the numbers. Straight away, you get it. And this is for B school A, and I just copy it here. The same thing happens. This is for A, this is for B. All of you explain to me what median is. So median, simply there is a formula. We could also do it at the other old-fashioned way, arrange it in ascending order and do all of that. But let's sort of use the formula. There is this formula called median. But we need to understand what median is. That is when you arrange the data set in ascending order, the number which comes right at the middle. Okay. So median is 16. Okay. Now, the way to understand median is there are at least 50% of observations lying below that number. Right. So for B school A, when I look at 16, which means it is 16 lakhs, which means half the students in B school A are earning above 16 lakhs. And at the same time, half of them are earning below 16 lakhs. And for this number, for B school B is 14 lakhs, which means half the students in B school A is earning above 14 and half of them are earning below 14. Okay. So mean, median. And I actually introduced the concept of skewness. I said, if the skewness, how do you determine if it's skewness? This data set is fairly simple. Simply by observing, you understand there are some big values in here. Let's say, for instance, I'm just looking at the second data set here. If I try to look at the big values, okay, of course, it is, I think, arranged in ascending order. So you find 53, 48, and 39. They are much, much bigger than 8.5 and 8.75. They're really large numbers. And they are in a lot of ways distorting the mean. Okay. So now, so you have the mean, you have the median. So I told you a median is a better representative value when the skewness is significant. Okay. If the skewness is above 1, instead of mean, we choose median as measure of central tendency. So let's look for the skewness now. That is SKEW, skew, and I take the number set, close it. Okay, that's 0.75. That's not a problem. Okay, if it's above 1 is when we have a problem. Okay, sorry, I think I should put this here. So SKEW, and for B, it's 1.1. It's above 1. So skewness for data set B is above 1, which means there are points in the data set which is making the data sort of let's say
biased. Data is biased.
Exactly, data is biased. Okay, so the moment you have a biased data set, a better sort of measure of central tendency is median. More reliable one is median. Okay. Now, I spoke about the percentile some time back. Okay, so could someone tell me what is a percentile? What do you understand by percentile? Let's say if I say 90th percentile, what is that? What do we mean by that?
So that means 90% of the observations lie below that particular observation point.
Okay, brilliant. Okay, I hope all of you understand this. Great. Okay, so essentially, I think the most common way, most of the times we hear about a percentile when it comes to the competitive examinations, particularly the common entrance test for admission to Indian Institutes of Management, IIM. They have CAT. We talk about 95th percentile, 96th percentile. So when you say somebody scored 95 percentile marks, it doesn't mean that he scored 95 out of 100 in the marks. It only means that he's better than 95% of the students who wrote the exam. So he's ahead of 95% of the people who wrote the exam. So let's say if 5 lakh people wrote the exam, he is better off than, let's say, 90% of 5 is 9 5 is 45. Okay, 4.75. He's better than 4.75 lakh people, which means he is the top 25,000 people who wrote the exam. Okay, when 5 lakh people write an exam and you say you are in the 90th percentile, let me put it as 90th. Okay, when you say 90th percentile, which means out of 5 lakh people, 9 5s are 45, 4.5 lakhs. So you're better than 4.5 lakh people who have taken the test. And you're in the top 50,000 people who have attempted. That's what it means. It doesn't mean that you've scored 90% marks or 95% marks, right? So now again, in our PowerPoint, is a PowerPoint visible now? Is a PowerPoint no, or do I have to?
Not yet.
No,
Excel file.
It's still the file. Okay. Okay, I'll have to do this every time, right? Okay, all right, that's fine. Okay, now, so the 30th percentile, okay, When I talk about 30th percentile, what it means is, if the 30th percentile score would imply that you are better than 30% of the students who are better in the class, which means 70% of the class is ahead of you, right? 30th percentile would mean at least 30% of the students are behind you, which would mean there are at most 70% ahead of you. At least 30 is behind you, and a maximum of 70% of the students are ahead of you. Okay, a minimum of 30 are behind you, a maximum of 70 is ahead of you. That is what you understand by 30th percentile. So your median is in fact the 50th percentile. So when you say median, it would mean 50% of the people are behind you, 50% are ahead of you. Now let's put this data into perspective now. For B school A, the average is 18.64, and for B school B, it is 21.89. So if you just looked at the average, you will find that B school B is better, which is what some of you were saying, yeah, high risk, high reward kind of thing. And average, you just look at the average. So 21.89 is certainly higher than 18.64. However, now you look at the median, this is where it becomes interesting. So at least 50% of students in B school A has got a salary of 16 lakhs per year, whereas the corresponding number for B school B is only 14 lakh. Right, so 50% of the students have got less than 14 lakh, whereas in A, 50% of students have got less than 16 lakh. Another way of saying it is 50% of students have got more than 16 lakhs in A, and only 50% in A, in B has got only more than 14 lakhs. So that number, in A, the median figure is higher, right? So if you're an average student in B school A, okay, average, when I'm saying, I'm using the loose English term of that. If you're just an average student in B school A, you're better off than the average student of B school B. Now, if you want to look for some more confirmation, you look at the percentile. Okay, so we have calculated the 30th percentile here. So what it means is, if you are like, if 70% of the students are better than you, which means you're somewhere bottom of the, so like slightly lower than the average student, like somewhere 30%, only 33, like 30% students are below you, 70 are ahead of you. Even in that situation, you notice that B school A, you actually take home 15.5 lakhs, and B school B, you take home only 10 lakhs, right? So three measures we've looked at. One is the average, next is the median, and the percentile scores. So on all these counts, I mean, I'm of the view that B school A is a better bet. Okay, somebody did mention that, okay, it's a high return, high risk sort of game if you join B school B. But if you look at data, if you just look at later, deepen data, and if you pose the same questions to students, I think someone who is a 30th percentile student with a 15.5 lakh student is going to be more inclined towards A, because much lower risk in terms of because whether you are the topper in the class or not is not entirely up to you. It also depends on the competition, right? It's not just your effort. There are other things also which are working towards how well you do in a class or what grades you score and all of those kinds of things, correct? So just wanted to talk about going deeper into data and figuring out what is the implication of that. Like, somebody did ask me something about median earlier. Can I come back to that, please? How to determine median? I did say that I'll come back to the question on median before we move ahead.
Yes, sir.
Yeah.
Here we are having 10 data sets. Suppose here we are having 11 data sets, so it's an odd number. So every time we will be getting a middle number, right? Okay. 5 and 5 and 1. Okay. So if suppose the data set is of an even number, suppose 10, okay, so there will be division of 5 and 5, right? Okay. So yeah. In that case, we are considering suppose 4 and 5, suppose whatever 5 and 6 or 4 and 5, whatever, and we take an average of the two, and then. And so what you do is, okay, fine. Yeah, okay. So I think let me just illustrate it again and come back to data set. Share the Excel sheet with you. Wait, is the Excel sheet visible now? Okay, yeah, it says, right? Okay, so what was being asked right now is this. Okay, now I'll come back to this. So how do we calculate
Where was I? Okay, this is it. Okay. Right. Okay. So now, how did I calculate the percentile? So percentile, I calculate this formula is equal to percentile and give the data set. And because I want 30th percentile, I put it at 0.3 and I get 15.5. Just copy it here, drag it here, I get for the other side. So 15.5 for B, school A, 30th percentile. Okay, fine. This is how you find the percentile. So I'll just quickly come to the question which was just raised now. So let's say we have data set here, let's say 2, 56, 34, 89. Okay, 4 numbers here. How do I find the let me put one more number, let's say 26. Okay, and I hope it's visible now. Okay, so this is the data set I have, 5 numbers in this data set. How do I find the median of this? Control C, Control V. I simply sort it. Okay, sort it. Okay, and how many numbers are there? There are 1, 2, 3, 4, 5. There are 5 numbers. Okay, so what did I tell you? How do we find the median? So we have 5 numbers in the data set. Okay, that is n is equal to 5. N is 5, and here you basically add n plus 1 by 2. That is 5 plus 1, 6, 6 by 2, 3. So this 3, this is going to be our median. That is 34 is going to be the median. Okay, the same thing you can actually use the formula here. Is equal to median. Take the data set. 34. Correct. Now the question that was asked is, because there are 5 data sets, there is an exact n plus 1 by 2 is, let's say, third. So you can pick up the third number. Suppose our data set had only 4 numbers. Okay. Suppose the data set had only, say, did not have this number 89. I remove the last number. What happens? So then what happens is your median is n plus 1 by 2. Median, so n is here. So that is 2 plus 1. That is 4 plus 1, 5. 5 by 2, 2.5. So now we need to find the number between 2 and 3 because the order is 2.5. So we take this number, that is the number between 2 and 3, which is like, yeah, between 2 and 3. Okay. So 2.5 is 4 plus 1 is 5. 5 by 2 is 2.5. So 2.5 is right in the middle of 2 and 3. And so that number would be 26 plus 34 divided by 2, because that is the number which is occurring between these 2 numbers. So 26 plus 34 by 2, and that is going to be 30. So your median is going to be 30. And this formula is actually corrected itself automatically. Okay, let me just look at it. Is equal to median. Right. Okay. So essentially, when you have even odd numbers in the data set, your median will actually be a part of the data set. Okay. If you have odd numbers in the data set, okay, if you have 11 numbers, then you will find that the median value will be part of the data set. If you have even number, then your median will not be part of the data set. So in this instance, you would notice that say 30. 30 is not part of the data set, right? But that is a median. However, if you have odd number of observations, invariably your median will be part of the data set. Okay, I hope that's understood, right? So I don't know who asked the question.
Yes,
yeah,
sir, thank you.
yes, Amita. Okay, do you got it?
Yes, sir, thank you.
Okay, yeah. So measures of, let me just reiterate. Measures of central tendency are 3: mean, which is the average, as we understand, sum all the observations divided by the number of observations. That's your mean. Median is arrange all the number in ascending order and pick the value right in the middle. Now, if it's odd number of observations, you will find that the median will be a part of the data set. However, if your number of observations is even, then you will find that the median won't be part of the data set. It will be actually average of the middle two values. Okay, so that's your mean, that's your median, and finally mode. Mode is the most repeated value which occurs in a data set. Now, because we're talking marketing analytics here, can anybody give an example of the application of mode with relevance to marketing? Where would value mode be most useful in marketing?
Analysis on sales of sales in supermarket.
Okay, and how is that number? Where is that number relevant? Okay, in supermarket, yes. So how is that mode relevant? Supermarket
To check what product is selling the most.
Absolutely, yes, brilliant. Okay, so essentially, yeah, if you look at the,
So they use it in this way in a supermarket. Suppose whatever product they want to push, suppose. So there are arrangements of racks there, right? So once a customer gets into it, not all the products are arranged in an eye line vision of a person, right?
True.
Some are at the bottom, some are at the behind, some you just come in and just first thing you look at is that product. So that is one of the arrangements that they do after getting the data analysis of the customers, which they get by doing a KYC of the customer. When the customer first comes in, they get the data of the customer, and by the data, they also scan the products. That is a way of knowing what customer is buying, what products, and the buying frequency of the type of brand they are buying. And by that, they want to arrange the brands of the particular products in a certain way that they will make more margin out of those products and try to push that that brand of that particular product instead of the another brand of the same product which has a higher margin than the other brand.
Great, absolutely. I mean, so both your answers are right. Essentially, yes, please, Shivam, go ahead.
Another example would be analyzing the survey data. For example, if you are trying to analyze the net promoter score, so you'll have multiple survey scores, and those are mode, right? Wherever the rating is, let's say 8 or 9, larger the number, the mode is for a particular rating, you can analyze it. So that's another part.
Okay, but I'm not quite sure, because when you analyze data like that, because you also have to factor in what is the response of other people. If maximum number of people are given a rating of 8 on 10, we can't disregard people who have given 2 out of 10 or 3 out of 10. So, that has to bring down the average. It might have its weight. If more number of people have said 6 on 10, of course, it might like sort of be towards 6 on 10, but I'm just saying you cannot disregard that. But the other example given by Srijan Dev and Amitav, they're more relevant. They say, let's say, for instance, in a let's say, showroom where you sell clothes, for instance. So white shirt, which white shirt? Is it XL or is it XXL or is it L or is it S? What size? So when you look at mode, you know which is the most repeated product. White shirt, XL. This is the one which sells the most. Or is it blue shirt, or is the blue one with striped? Each one is coded differently, right? So then when you just look at the mode, okay, which is the fastest moving shirt. Whether it's a white shirt with collar, white shirt with cuff, white shirt with an XL size, or all of that sort of stuff. So from a marketing perspective, store sales mode is the value which tells us what is your best selling or the fastest selling or quickest moving product. All right.